Hello there, and welcome to this quiet corner, where curiosity can take its time, and science is allowed to unfold without hurry. Tonight, we're not staying in the present. We're stepping far back, so far that even the world beneath our feet will no longer look familiar. This is a journey into an Earth that existed hundreds of millions of years ago, long before cities, before oceans as we know them, and even before the map of the world began to resemble the one in your mind. This is the story of Pangea, a single massive continent that once stretched across much of the planet's surface, holding nearly all the land on Earth in one unbroken sweep. It is a name many people have heard in passing, tucked between diagrams in school books or mentioned in quiet documentaries. Yet few stop to imagine what it would have actually been like. What would you see if you could stand there? How would it feel to breathe that air, to walk across a landscape that had no familiar boundaries, and to look at a sky that had not yet been framed by the geography we know? To understand this world, you first have to let go of the map that lives in your head. There was no Atlantic Ocean splitting the Americas from Europe and Africa. There was no vast Pacific cutting across the center of the globe. Instead, there was one continuous landmass. If you could have walked across it, you might have begun in the north of what is now North America and kept moving east, crossing into what we now call Europe and Asia without ever setting foot on a ship. You could have turned south and passed into Africa and South America without ever seeing an ocean break the horizon. There was only land stretching farther than any traveler could hope to walk in a lifetime, bordered by a single immense ocean that wrapped around it like a ring. This world, however, was not quiet. It was not a place of stillness, frozen in deep time. The Earth has always been restless, and in the age of Pangea, it was no different. Powerful forces moved beneath the surface, invisible but unrelenting. They pushed continents together, welding them into one. They folded mountains out of the crust, split deep valleys, and sent volcanoes rising to paint the sky in fire and ash. And at the center of this enormous land, life unfolded in conditions almost unimaginable to us. Far from the ocean, the climate was harsh. Without seas to carry moisture inland, there were vast stretches of arid land where rain rarely fell. Summers could turn into suffocating heat, while winters brought biting cold. The seasons were intense, the air dry, and the sky seemed to stretch endlessly, broken only by the outline of mountains in the far distance, or the silhouettes of forests adapted to this demanding world. Even so, life filled every corner. Towering plants covered parts of the landscape, while in other regions, red deserts rolled toward the horizon. Creatures you would not recognize walked across that ground. Strange reptiles, some with features that hinted at the first mammals and insects that grew, far larger than any you would see now. The Earth was alive, but it was a different kind of life, one shaped by the strange rules of this unified world. And perhaps the most striking thing of all was the absence of boundaries. Today, we're used to a planet cut into pieces by oceans, but in the age of Pangea, there were no such barriers. A river could begin in what we now call Asia and wind its way into what would become Europe without ever being stopped by a sea. Forests could stretch across regions that would one day be split into entirely different continents. The same species of animals could roam freely from one end of the land to the other. It was one Earth undivided, its surface open and connected in a way that is almost impossible for us to imagine now. Yet for all its size, Pangea was never permanent. The forces that built it were always at work, and even as they held it together, they were preparing to tear it apart again. That is the nature of this planet. Continents drift, oceans open and close, mountains rise and fall. But while Pangea lasted, it left marks that can still be seen today, shaping the evolution of life and carving out the deep foundations of the world we know. Before we reach the moment when Pangea first began to split, we need to begin even earlier with the forces that brought it into being in the first place. Because to understand what it was like to live on that ancient continent, we first need to understand how the Earth gathered itself into one. The The story begins not with a single dramatic event, but with slow, constant movement. Beneath our feet, the Earth's crust is broken into enormous plates that glide over the softer, hotter material beneath. This motion is gradual, measured in centimes per year, but given enough time, it reshapes the entire face of the planet. Long before Pangea, there were other supercontinents, Rowenia, Nuna, and others whose names are rarely spoken outside geology classrooms. They came together, they broke apart, and their pieces drifted, setting the stage for Pangea to rise. Over hundreds of millions of years, smaller continents and island chains collided, merging into larger and larger land masses. Each collision folded mountains into the sky, built long ranges of stone, and left deep scars in the crust. These ancient seams still exist today, hidden in the bedrock beneath our feet. Slowly, these pieces fused together, until at last, the Earth held only one vast land. It is almost impossible to grasp the scale of this. Imagine standing in the interior of Pangea, thousands of kilometers from the nearest ocean. The air would have been different, the climate harsher. There would have been no familiar sense of proximity to a coast, no smell of salt on the breeze. It was a world of interiors, of deep continental heartlands, where seasons could turn extreme, and isolation was profound. And yet, this very isolation shaped the living world. Insects grew in size, perhaps because of higher oxygen levels in the atmosphere. Reptiles adapted to survive in the dry heat of the interior, while in other regions near the coasts, early forests created green corridors for life to spread. It was in this crucible of shifting climates and connected landscapes that many of the ancestors of future creatures, dinosaurs, mammals, and even early birds would eventually emerge. The land itself bore marks of constant change. Volcanoes erupted, painting the sky with ash that would settle into the soil. Rivers carved long valleys, carrying minerals from the rising mountains to the lowlands. Deserts expanded and retreated with the seasons. It was a planet in motion, but one bound together by a single colossal continent. And everywhere you looked, the signs of that unity were written in stone and sky. Even the winds must have felt different. On a modern Earth, oceans break up and redirect global air currents. But in the time of Pangea, the absence of those dividing seas meant that wind could sweep across thousands of kilometers with little interruption. Dust from inland deserts could have blown all the way to the coastal edges, feeding nutrients into distant forests. Storms might have traveled further, unbroken by oceanic boundaries. The entire planet's climate was influenced by the simple fact that nearly all the land was in one place. And so in this ancient world, every sunrise would have lit a horizon shaped by a single connected Earth. No distant continents to imagine, no hidden lands across vast oceans, just one world, whole and immense under the same sky. Before there was one great landmass, the Earth was a very different place. Hundreds of millions of years before Pangea came together, the planet was a patchwork of smaller continents, scattered across the globe and drifting slowly over a deep, ancient ocean. These fragments of land did not stay in one place for long, at least not on geological timescales. They moved, as they always do, carried on the slow conveyor belts of tectonic plates. Mountains rose where they collided, oceans opened when they split apart. Each shift was measured not in days or years, but in millions of years. And yet, every small movement was another step toward the creation of a single united world. To understand how this happened, we have to imagine the Earth during the late Paleozoic era, roughly 300 million years ago. By this time, several large continental blocks were already drifting across the planet. Laurentia, which would become North America, Gondwana, which included the future land masses of South America, Africa, Antarctica, Australia, and India, and smaller pieces like Baltica and Siberia. These were not yet connected, but they were on a slow collision course that would eventually bring them together in one colossal embrace. The process began with earlier supercontinents long before Pangea. There was Rodinia, which existed nearly 1 billion years ago. When it broke apart, it scattered fragments of land into new positions, only for them to regroup later into another supercontinent called Pangaea. That one was short-lived. It too fractured, but its pieces began drifting toward one another again. These repeated cycles of assembly and separation are part of what geologists call the supercontinent cycle, a natural rhythm of the Earth's crust driven by the movement of tectonic plates. As these fragments drew closer, oceans shrank between them. The Rick Ocean, for example, once lay between La Russia, an early fusion of North America and parts of Europe, and Gondwana. Over millions of years, that ocean narrowed until it vanished entirely, crushed out of existence by the merging continents. When land meets land, the collision is not gentle. Rocks crumple like paper under enormous pressure. Whole mountain ranges rise where two plates lock together. The Appalachian Mountains in North America and parts of the Atlas Mountains in Africa are relics of these ancient impacts. The scars of collisions that helped stitch Pangea together. The world during this time would have looked strange from above. You would see great land masses creeping toward one another, surrounded by an immense global ocean called Panthalassa. As the continents converged, island chains were swallowed up, their volcanic peaks crushed between colliding plates. Shallow seas vanished. The boundaries between one landmass and another blurred, until at last all of them became one. But while this slow-motion collision was happening, the climate was changing as well. Large ice sheets still clung to parts of Gondwana, especially in regions that would one day become South America, Africa, and Antarctica. Evidence in the rocks, scratches left by ancient glaciers, tells us that even during the assembly of Pangea, the Earth swung between colder and warmer intervals. As the continents collided and closed off smaller seas, ocean currents shifted and the atmosphere began to take on a new rhythm. These changes in climate were not simply background details, they shaped the living world. When continents crash together, they create vast new highlands, and mountains change everything around them. They redirect wind, they trap moisture on one side, while casting long rain shadows over the other. In the age before Pangea fully formed, these shifting landscapes were already sculpting the path of evolution, setting the stage for what kinds of plants and animals would thrive when the supercontinent finally came to be. If you could stand on Earth in this time, you would see landscapes that felt familiar in some ways, but alien in others. Vast stretches of lowland swamp-covered parts of what would become North America and Europe, towering forests of primitive trees spread across the horizon. These were the Carboniferous forests, so dense and humid that their decaying plants would one day form the coal seams we still mine today. The air was rich in oxygen, higher than what we breathe now, and that made it possible for some insects to grow to enormous sizes. Dragonflies with wings nearly a meter across skimmed above those forests. Giant millipede-like arthropods crept along the forest floor. It was a world that felt heavy with life, an Earth still experimenting with what it could become. To the south, Gondwana told a different story. Much of it lay closer to the polar regions where glaciers carved across its surface. These frozen expanses were nothing like the warm swamps near the equator. Yet, they existed at the same time, part of a planet in transition. As the continents crept toward each other, climate zones shifted, drawing cold regions northward and pressing warm regions southward, until finally they began to blend into a new, global order. And then, over millions of years, the last great collisions began. La Russia struck Gondwana, and mountain ranges buckled skyward. The smaller plates that once floated in between were caught and crushed. This was the moment Pangea truly began to take shape. It was not a single event, but a long series of impacts and merges, each one pushing the planet closer to the world-spanning continent that would define an entire geological age. By the end of this process, the map of the Earth would have looked starkly simple. Nearly all the land on the planet sat fused into one vast expanse. Around it, Panthalassa stretched outward in every direction, a single global ocean that reached the edges of the horizon no matter where you stood. Along one side of Pangea, an inland sea known as the Paleoteeth still lingered, a remnant of older oceans that had not yet fully closed. But even that would eventually fade, swallowed up as the continents pressed tighter together. And so the stage was set. The world had gathered itself into a single piece. The last collisions had passed. The mountains stood high. The deserts were already beginning to form in the deep interior, and the climate was shifting into patterns that would shape life for millions of years to come. But this was only the beginning of Pangea's story. Now that the continents had come together, the world was about to change in ways far more dramatic than the slow collisions that created it. With the continents locked together, the Earth entered one of the most remarkable chapters in its history. Pangea was no longer an idea in motion. It was real. The long collisions that had drawn land masses across thousands of kilometers were finished, and the world now stood as a single unified continent, surrounded by an immense ocean. It was an Earth without the familiar divisions of today, and its sheer scale would have reshaped every part of the planet's surface. The making of Pangea was not simply the merging of continents, it was the transformation of the entire Earth system. Mountain ranges rose where land had crumpled in the collisions. Deep scars in the crust became sutures, welding the fragments into a single piece. These scars remain visible even now. Geologists still trace them across continents separated by oceans, evidence of the places where once long ago they were joined. The collision zones were violent. When plates crash together, the crust folds and fractures. Heat builds as rock grinds against rock. Magma forces its way upward, feeding chains of volcanoes that can run for thousands of kilometers. In Pangea's birth, this process was relentless. The central regions of the supercontinent were shaped by the uplift of mountains that rivaled the scale of the Himalayas today. These ranges would later erode, their peaks worn down by time, but in their prime, they mark the raw power of the planet's restless crust. At the same time, vast basins opened between those ranges. Rainwater and runoff from the new mountains carved wide river systems, cutting across the supercontinent's interior. These rivers fed wetlands and deltas that became some of the most fertile regions of their time. Fossils, preserved in these ancient basins, tell the story of lush ecosystems that thrived in the shadow of the newly built highlands. But the formation of Pangea also created a new kind of land, one the Earth had never seen at such a scale. As the continents fused, the interior of this vast landmass moved farther and farther from the moderating influence of the sea. The result was a continental core so distant from the ocean that moisture from coastal regions rarely reached it. This gave birth to enormous deserts, some of which may have stretched for thousands of kilometers. The great expanse of the supercontinent center was a land of extremes, a place where scorching summers and bitter winters ruled, while the edges of Pangea, near the surrounding ocean, remained wetter and milder. This pattern of dry interiors and wetter coasts was one of the defining features of Pangea. Even now we can trace it in the rock record. Red beds, layers of iron-rich sediment that formed in hot, arid conditions, are scattered across the continents that once made up Pangea. These rocks are the ancient footprints of the deserts that spread across its heart. Meanwhile, coal deposits formed in swampy, humid regions tell us that near its coasts, dense forests flourished under heavy rains carried inland from the sea. The climate of Pangea was not only shaped by its size, but also by its position. During the height of the supercontinent's existence, much of it straddled the equator. That meant vast tropical belts crossed its middle, bringing heat and seasonal monsoons to some regions, while its southern and northern extremes reached deep into polar latitudes. No other arrangement of land in Earth's history has combined such an enormous range of climates on a single connected continent. From frozen southern ice sheets to equatorial rainforests, All of it existed on one continuous piece of land. Life adapted to these extremes. In the warm, wet regions near the coasts, dense forests of seed ferns and towering coniferous trees covered the land. Their roots stabilized the soil, while their leaves formed vast green canopies that trapped humidity. These forests were home to early reptiles, amphibians, and an array of invertebrates, including insects of remarkable size. In the arid interior, life told a different story. There, plants evolved strategies to conserve water, and animals adapted to long stretches of heat and scarcity. It was a world of survival, where every adaptation was a response to the demands of an immense and unforgiving landscape. The making of Pangea also changed the oceans, with nearly all of the land gathered in one place. The surrounding sea, known as Panthalassa, became the dominant global ocean. Its current circled the supercontinent, redistributing heat around the planet. Meanwhile, along one edge of Pangea, the shrinking Paleoteus Sea persisted. An isolated remnant of earlier oceans, this sea became a vital pathway for marine life, a sheltered environment where reefs and shallow water ecosystems thrived even as the open ocean remained vast and deep. This arrangement of land and sea created powerful wind systems. Without the complex shapes of modern continents to break their flow, global wind patterns became more direct and intense. Seasonal monsoons swept across parts of Pangea, carrying heavy rains to some regions, while leaving others in perpetual drought. Dust from the interior deserts may have traveled immense distances, carried by winds across thousands of kilometers, before falling into the coastal forests, or even settling into the ocean. But perhaps the most striking result of Pangea's formation was its influence on life's future. By uniting all the continents, Pangea erased the barriers that had once separated ecosystems. Species that had evolved in isolation now came into contact with one another. Predators followed prey into new territories. Plants and animals spread into regions they could never have reached before. This mixing of life would shape evolutionary paths for millions of years. Fossils found today, in places as far apart as South America, Africa, and India, are often nearly identical. Proof that during the age of Pangea, the same species walked across lands that are now separated by entire oceans. Even as Pangea stabilized, it was never truly at rest. Deep within the earth, the same forces that had assembled it continued to move. Heat built beneath the crust, slowly weakening it in places. Faults formed, invisible at first, but these fractures would one day become the starting points for the great breakup that would scatter the continents again. But for now, Pangea stood whole, an extraordinary arrangement that dominated the surface of the earth and defined an age. To walk across it then would have been to see the planet in a way no one can see it now. There was no distant coastline hidden beyond the horizon, no foreign continent waiting across an ocean. There was only one world, vast and connected, bound by the same sky, the same winds, and the same restless heartbeat of the earth beneath it. And it was here, in this unified world, that the next great chapter of life's history would begin. With the earth gathered into one colossal landmass, the idea of distance changed forever. There were no oceans dividing one region from another, no isolated continent separated by thousands of kilometers of open water. Pangea was a single continuous world, from one horizon to the next. The land stretched on, unbroken by the familiar boundaries that shape our planet today. To understand this, imagine standing somewhere near the center of that vast continent. You could walk in any direction for months and never see the glint of an ocean on the horizon. Instead, you would cross plains so wide that the sky seemed larger than it does now. You would pass rivers that wandered across entire regions, weaving through landscapes that had no borders. You would move from one climate to another, not because you had crossed an ocean, but because the land itself was so enormous. The weather shifted gradually over unimaginable distances. This was not a world of isolated ecosystems. In our modern age, oceans create natural barriers that separate species, giving rise to unique forms of life on each continent. But on Pangea, those barriers did not exist. Plants and animals could spread freely, crossing vast stretches of land without ever being stopped by a sea. Fossils prove this. Identical species have been found on continents that are now separated by thousands of kilometers of ocean. Reptiles that once lived in what we now call South America also left their bones in Africa. Early plant species stretched across regions that today are scattered around the globe. Pangea allowed life to move as if the entire world were one single connected habitat. The absence of borders also changed the way the land itself behaved. Winds could travel farther, unimpeded by mountain chains or broken coastlines. Massive air currents swept across Pangea, carrying heat and dust from the dry interior toward the coasts. Rainfall, on the other hand, struggled to reach the heart of the continent. Moisture from the surrounding ocean would fall as rain along the edges of Pangea, feeding dense forests and wetlands. But by the time the air reached the deep interior, it had little left to give. What remained were vast, arid zones, deserts so expansive that they stretched farther than the modern Sahara. These dry regions formed a stark contrast with the humid belts near the coast, making Pangea a world of extremes. The rivers that cut across the supercontinent carried more than water. They were highways for life. Early amphibians followed them from one region to another, their movements guided by the steady flow of fresh water. Along their banks, strange forests of ancient conifers and seed ferns created green corridors that connected one part of Pangea to the next. Some rivers were so long that in our time their courses would cross multiple continents. Yet in Pangea, they were simply part of a single boundless landscape. And there were mountains, huge ranges born from the collisions that created Pangea in the first place. These mountains rose where continents had once met head-on, their crumpled layers thrust toward the sky. Some of these ranges were immense, stretching across distances so great that they tied the land together like seams. Over time, erosion wore them down, and rivers carried their sediments into the lands, enriching the soil and feeding vast floodplains. Traveling across this supercontinent would have meant passing from one environment into another in a slow, steady transition. From humid coastal forests, you would move into open savannas and grasslands. From there, you would enter deserts that seemed endless, their red sands broken only by rocky outcrops and the occasional winding river. Farther still, you might find forests again, fed by mountain rains that created their own small climates within the larger whole. Pangea was unified, but it was never monotonous. Its sheer size allowed every kind of landscape to exist side by side, all stitched together on one colossal piece of land. The absence of borders also shaped the movement of animals. Early reptiles, the ancestors of creatures that would one day dominate the planet, could travel enormous distances across Pangea without encountering an ocean. They spread out across this vast land, adapting to its many environments. Some settled in the wetter coastal forests, while others learned to survive in the dry interior. This mobility allowed species to spread quickly and widely, creating ecosystems that spanned much of the supercontinent. Even the sky must have felt different. On modern Earth, coastlines break the flow of wind and create regional weather systems. On Pangea, the land was so massive that weather could roll across it for thousands of kilometers. Without interruption, storms that formed near the coasts might sweep deep inland, their rain dwindling until it was nothing but dry wind. Monsoons could reach staggering scales, with seasonal shifts that drenched one side of the continent while leaving the other in crushing drought. Despite all of this, Pangea was not an empty, silent place. It was alive. Primitive forests stretched across entire regions. Swamps near the coast teemed with amphibians and early reptiles. In the arid interior, tough, drought-resistant plants anchored the soil against the sweeping winds, while smaller animals darted between patches of shade. Even in its harshest landscapes, life persisted, carried across the continent by its open, unbroken reach. If you could stand there and look around, it might have been overwhelming. No horizon was close enough to feel familiar. No ocean offered a natural edge to the world. Everything stretched outward, in every direction, as though the planet itself had grown larger. That sense of scale would have defined daily life on Pangea. Travel was slow, movement was vast, and even the sky seemed to match the land beneath it in its immensity. This was a world where everything was connected, where mountains, deserts, forests and rivers were all part of a single continuous earth. It was this unity that gave Pangea its power. It shaped the winds and the rains. It guided the spread of plants and animals. And it prepared the stage for the next great transformations in the history of our planet, when this vast borderless land would begin to evolve and challenge every living thing that called it home. Although Pangea was one continuous continent, it was not uniform. Its edges and its interior might as well have been different worlds. Along the coasts, the influence of the surrounding ocean shaped the land. Humidity from Panthalassa carried inland on steady winds, feeding lush forests and swamps, where life thrived in abundance. But the further you moved away from those coasts, the less of that oceanic influence remained. Step by step, the green of the coastal regions faded, replaced first by open plains, and eventually by the stark arid expanse of Pangea, vast interior deserts. The coasts were places of constant motion and life. Warm, shallow seas met the land in wide tidal flats nesties, where the boundaries between land and water blurred. Here, amphibians lingered near rivers and wetlands. Early reptiles hunted in forests of towering conifers and seed ferns. Insects, some of them far larger than their modern relatives, buzzed through the humid air. The climate in these regions was warm and wet, regulated by the nearby ocean, and it allowed ecosystems to flourish, much like the tropical belts of our world today. Fossils from these coastal zones show dense vegetation and an extraordinary diversity of species. Some areas likely resembled the mangrove swamps of the modern world, with twisting roots and slow-moving waters teeming with early fish and invertebrates. Farther inland, but still within reach of the ocean's moisture, sprawling river systems cut through the land, feeding broad floodplains where forests grew thick and green. These regions would have been the most habitable parts of Pangea, rich with food and shelter, their seasonal cycles predictable and steady. But every step away from the coasts carried you closer to a different kind of world. In the deep interior of Pangea, rainfall was scarce. The same immense size that allowed Pangea to connect nearly all of Earth's land also gave it one of its most defining features: a continental heartland so far from the sea that it became a desert on a scale no modern landscape can match. These deserts were not small patches of sand like those we think of today. They were vast, stretching for thousands of kilometers, broken only by occasional rocky uplands or isolated rivers. Geologists have found evidence of these regions in the form of red beds, layers of iron-stained rock formed under hot, dry conditions. These rocks tell us that much of Pangea's interior was a land of relentless sun and minimal rain, where only the hardiest forms of life could survive. In this interior, the air would have felt heavy during the day, the heat radiating off the ground in shimmering waves. At night, without the insulating presence of clouds or nearby oceans, the temperature would have dropped sharply, leaving the land cold under a canopy of brilliant stars. It was a world of extremes, where survival demanded resilience. Plants here were sparse and tough, their roots deep, their leaves hardened against the loss of water. Small reptiles and early mammal-like creatures adapted to this environment, burrowing for shelter or becoming active during cooler hours to avoid the punishing sun. Between these deserts and the coastal forests were transitional zones, regions of grasslands and open woodlands where the climate shifted gradually from wet to dry. These belts may have been the great highways of life on Pangea, corridors that allowed animals and plants to move between different parts of the continent. Along these routes, species spread across the supercontinent, creating the widespread, fossil patterns that scientists find today on continents now divided by oceans. Meanwhile, the coasts themselves were far from uniform. Some regions faced steady rainfall and supported dense swampy forests, while others lay in the rain shadows of massive mountain ranges, leaving them drier than their latitude might suggest. Monsoonal winds, driven by the immense size of Pangea and the seasonal shift of the sun, brought alternating floods and droughts to certain coastal zones. The land was never static. Every year, storms swept inland, rivers swelled and then shrank, and forests adapted to cycles that repeated for millions of years. The contrast between the coasts and the interior shaped more than just the landscape. It also influenced the behavior of the animals that lived there. Coastal regions were rich in food and supported a wider range of species. In the deserts, competition was fierce and life was specialized. Fossils show creatures in these arid zones with unique adaptations, from burrowing habits to specialized teeth designed to survive on tough, dry vegetation. Life was not evenly distributed across Pangea, but it was interconnected. The rivers flowing from the mountains to the coasts, the winds carrying dust from the deserts to the forests, and the migration paths of animals, all tied these environments together. Even the air itself carried traces of this interconnectedness. Dust storms from the interior deserts likely traveled far, spreading minerals across Pangea and even into the surrounding ocean. This constant movement of material linked the land and sea, feeding nutrient cycles that help sustain ecosystems on both. To walk across Pangea would have been to pass through these sharp contrasts, from the wet, teeming forests of the coasts to the empty, sun-baked expanses of the deserts, and finally back again as you neared another distant sea. It was a single world, but it contained within it climates and landscapes that today would be separated by oceans. This was the true scale of Pangea, a land so vast that it carried its own extremes within it. And yet, despite these differences, this single supercontinent was not a static or finished creation. Its mountains still shifted, its climate continued to evolve, its deserts grew and shrank, while its coastal regions changed with the rise and fall of ancient. It was a world in motion, and that motion was far from over. The deeper you moved into the heart of Pangea, the farther you left the ocean's influence behind. Moisture from the coast did not reach this far. Winds lost their strength, and the air grew dry under an endless sky. This was the great interior, a land defined not by what it had, but by what it lacked. Here, rain was a rare visitor. Months could pass without a single storm, and when the clouds finally gathered, their showers would vanish almost as quickly as they arrived, swallowed by the thirsty ground. This interior was vast, stretching for thousands of kilometers in every direction. Modern deserts like the Sahara or the Gobi may seem enormous, but they are small compared to the dry expanses that dominated Pangea's center. Geologists studying ancient rocks have uncovered layer after layer of red sandstone, iron-stained and baked in heat, proof of an arid world that endured for millions of years. These layers show a landscape sculpted by sun and wind, where rivers were few and lakes were temporary, vanishing when the short-lived rains faded again. The climate here was harsh and unrelenting. During the day, the sun beat down without mercy. Without clouds to soften its glare, the ground would have heated until the air shimmered with the waves of rising heat. At night, the temperature dropped sharply. With no moisture to hold on to the warmth, the land cooled quickly, leaving the air cold and thin under a dome of stars. Life in this environment had to bend to its rules or vanish entirely. Plants in this interior were sparse, but they were far from absent. Low, hardy vegetation clung to the soil. Early conifers, seed ferns, and other drought-resistant species adapted to the constant struggle for water. Their roots reached deep, searching for moisture trapped far below the surface. Between these isolated pockets of green, stretched wide plains of dry earth and rock, interrupted only by scattered dunes and the faint traces of ancient riverbeds. These rivers, when they flowed at all, often ran only briefly before fading into the ground or evaporating under the relentless sun. Animals that ventured here carried the same marks of adaptation. Many were small, their bodies built to lose little water. Some burrowed deep underground, escaping the daytime heat and emerging only when the sun dipped low. Others moved along the edges of the few surviving rivers, living on whatever water and vegetation they could find. Early mammal-like reptiles left their tracks in this land, alongside the footprints of smaller predators and the occasional larger herbivore that followed the seasonal shifts in search of better grazing grounds. The wind was a constant companion in the great interior. With no forest to hold it back, it swept across the open land, carrying dust from one horizon to the next. Over millions of years, this dust left its mark, settling in layers that still remain locked in the rock record. It would have been a world of muted colors, reds and browns baked by the sun, pale skies that shifted from dazzling blue to deep star-strewn black, and little else to break the monotony except the jagged outlines of distant mountains. Yet this harshness was not lifelessness. Even in this dry core of Pangea, ecosystems endured. Small oases existed where underground springs surfaced. Seasonal floods from distant mountains carved temporary rivers through the parched land, drawing life from every direction. Fossils from these areas reveal sudden bursts of activity, evident that for brief moments, these arid regions came alive when water returned, only to fall silent again when the heat reclaimed them. The size of this interior created another challenge: isolation for animals and plants that lived in the heart of Pangea. The distances were staggering. Migration from one fertile region to another could take generations. Populations became specialized, shaped by the demands of the dry environment until they no longer resembled their relatives from the coastal forests. This slow process of adaptation was one of the great engines of evolution in Pangea's interior, producing species that could endure conditions few others could survive. The wind-driven climate also reshaped the land over time. Without heavy rainfall, erosion moved slowly. Rocky outcrops that formed during Pangea's creation remained exposed for millions of years. Their surfaces scoured but not erased. Sand, carried by the constant gusts, sculpted dunes and carved patterns into stone. These marks of ancient weather remain preserved in the rocks we study today. Silent witnesses to a world where the desert seemed endless. Despite its severity, the great interior was deeply connected to the rest of Pangea. Dust from these dry lands drifted outward, carried by the wind into the wetter regions near the coasts, feeding distant forests with minerals. Seasonal storms, though rare, sometimes formed along the edges of the interior and swept outward, pushing dry air into greener lands and shifting weather patterns far beyond the desert's reach. In its own way, this empty expanse influenced the entire supercontinent, tying the fate of its interior to its coasts. To travel through the heart of Pangea would have been to experience silence on a scale almost unknown today. No sound of waves, no dense canopy of leaves rustling in the wind, only the sweep of air across stone and the occasional cry of an animal adapted to the emptiness. And yet, this silence was not empty of meaning. It was here, in this great arid core, that life learned to endure its harshest tests, preparing for the challenges that lay ahead in the changing world to come. While the heart of Pangea was dominated by dry winds and empty horizons, its edges were shaped by an entirely different force: the surrounding ocean. Panthalassa, the vast global sea that bordered the supercontinent, stretched outward in every direction, so immense that even from the coasts of Pangea it may have seemed endless. This single ocean was not merely a backdrop, it was one of the most powerful influences on the climate, ecosystems, and movement of life across the planet. Where the land met the sea, the world was transformed. Moisture carried inland by ocean winds fed the coastal regions, creating belts of life far greener than the barren interior. These areas were home to rivers swollen by seasonal rains, wetlands alive with primitive amphibians, and forests so dense that they formed nearly unbroken canopies in some regions. It was along these coasts that life thrived most abundantly, sustained by the constant interaction between land and water. The ocean itself was no less extraordinary. Pangea covered nearly 3/4 of the planet, its deep currents circulating slowly but with immense reach. With only one massive continent to disrupt its flow, its waters moved around Pangea in vast loops, distributing heat from the equator toward the poles. This steady movement helped regulate the climate of the coasts while leaving the interior lands to their extremes. Near the shorelines, however, Pangea's influence was immediate and visible. Warm, shallow seas flooded low-lying regions along the continental margins. These shallow zones, sometimes stretching for hundreds of kilometers, were ideal for life. Ancient reefs built by early corals and sponges rose from the seabed. Schools of primitive fish swam through clear waters, while trilobitetic arthropods, though nearing the end of their reign, still clung to survival in isolated pockets. In these coastal waters, nutrient cycles connected the land to the sea. Rivers from the interior carried sediments rich with minerals, feeding the shallow marine ecosystems. These nutrients fueled blooms of plankton, which in turn supported a growing web of marine life. Fossils from these ancient seabeds tell a story of abundance. Fishes of many forms, invertebrates with strange ornate shells, and predators that patrolled the waters long before the first dinosaurs walked on land. The coasts were also shaped by the ocean's moods. Seasonal monsoons, driven by the immense size of Pangea, brought powerful storms to its edges. These rains replenished the rivers and wetlands, but they also brought flooding, reshaping the landscape year after year. In some regions, these storms may have carried salt-laden air inland, leaving behind crusted flats where water evaporated faster than it could collect. Each cycle carved another mark into the land, building a coastline that was in constant motion. Despite the challenges of its interior, Pangea's coasts were places of connection. They linked the land to the ocean and acted as gateways for life between those two worlds. Amphibians ventured into the wetlands to lay their eggs, relying on the steady flow of fresh water. Reptiles followed, evolving traits that freed them from dependence on aquatic breeding, giving them the ability to move farther inland. Even the first primitive ancestors of mammals likely emerged near these coasts, their survival tied to the rich ecosystems that stretched between the sea and the land. The air along these edges would have been thick with life. Insects buzzed through forests that bordered tidal flats. Early reptiles basked on sun-warmed rocks beside shallow lagoons. Primitive ferns and seed plants flourished in the humid climate, their roots gripping the nutrient-rich soil washed down from distant islands. Every part of the coast was alive with movement, and every season brought new growth, new migrations, and new struggles for survival. But just as the ocean gave life, it also drew clear lines of contrast. While the coast were lush and dynamic, a few hundred kilometers inland, the greenery would fade. Rainfall diminished, and the air grew drier. The ocean's reach was powerful, but it was not limitless. The sharp gradient between fertile coastal zones and the arid interior was one of Pangea's defining features, a reminder that even on a world of connected land, the edges in the center lived by very different rules. The ocean itself, though seemingly constant, was far from still. Its tides and currents shaped erosion along Pangea's coasts, cutting into cliffs and depositing sediments in new places. Some regions drowned under shallow seas for millions of years before the water retreated. Again, others rose upward as the Earth's crust shifted, exposing once submerged seafloors to the air. This constant exchange between land and sea created a shifting map that forced life to adapt. again and again. And Panthalassa was not alone. Along Pangea's eastern edge lay the Paleoteeth Sea, a smaller but equally important body of water. It was here, in this relatively sheltered sea, that many early marine species found stable habitats. Shallow waters protected by long continental shelves became cradles of evolution, feeding a diversity of creatures that would later spread to the larger ocean. This sea was a counterpoint to Panthalas's deep open expanse, offering quiet refuge while the rest of the planets were churned in their vast uninterrupted gyres. Standing on Pangea's coastline, you would have seen no distant islands, no neighboring continents rising from the waves, only the open ocean stretched to the horizon, an endless blue void that surrounded the one connected landmass on Earth. The sound of waves against the shore, the cry of primitive reptiles from the nearby forests, and the steady winds sweeping inland would have been a reminder that this world was vast, unbroken, and still in motion. The oceans at the edge of everything were not just boundaries, they were the living, breathing skin of the planet, binding water, air, and land into a single system that set the rhythm for life on Earth. And from these coasts, the story of Pangea would continue inward again into the forests and plains that stretched between sea and desert, where the planet's strange and evolving life would take its next steps. The air of Pangea was not the same air we know today. It was thicker in some ages, thinner in others, and its very composition left its mark on the creatures and plants that filled the world. To step outside and breathe during this ancient time would have been to inhale an atmosphere shaped by a planet in transition, one that carried both the weight of its geological past and the potential for everything that was still to come. Evidence locked in rock layers tells us that oxygen levels during parts of Pangea existence were higher than what we breathe now. In the late Carboniferous period, just before Pangea reached its full form, oxygen may have made up as much as 30% of the atmosphere, compared to 21% today. That extra oxygen changed everything. It fueled the growth of enormous insects and arthropods, creatures that depended on simple diffusion to deliver oxygen through their bodies. Dragonflies with wingspans longer than a human arm soared over dense forests. Millipedic invertebrates grew to lengths that would be startling in any modern landscape. The air quite literally allowed them to become giants. Yet the atmosphere did not remain constant. As Pangea stabilized and entered the Permian period, oxygen levels began to decline. By the middle of that era, they may have dropped closer to 15%. Breathing in such conditions would have been challenging for modern humans, but the animals of that time were adapted to it. Their lungs and circulatory systems evolved to draw every bit of oxygen they needed from the thinning air. The shift reshaped ecosystems, favoring species that could endure lower oxygen and gradually pushing the oversized insects of earlier ages into decline. Carbon dioxide, too, played its part. Volcanic eruptions along Pangea's fault lines released vast amounts of it into the atmosphere, warming the planet and fueling powerful weather systems. This greenhouse effect helped keep the coastal forests humid and lush, while in the great interior, the heat only deepened the aridity. The very chemistry of the air was tied to the geology of the supercontinent. Each eruption and each tectonic shift influencing life in ways that could be measured in the straw bones of the animals that survived. For plants, this atmosphere was both a challenge and an opportunity. High levels of carbon dioxide favored the growth of massive forests. Seed ferns, towering conifers, and other ancient plants thrived, their leaves pulling in the gas and releasing oxygen in return. These forests became vast oxygen factories, feeding the planet's atmosphere and anchoring the climate. When they spread along river valleys and coastal lands, they created pockets of breathable abundance in a world otherwise dominated by extremes. But the connection between air and life ran deeper still. Atmospheric circulation, the movement of air around Pangea, was unlike anything on Earth today. With nearly all the land gathered into one block, wind patterns became larger and simpler, moving unimpeded across thousands of kilometers. Warm air rose above the equator, driving powerful monsoons along the coasts, while cooler, dry air descended into the interior, feeding the deserts that sprawled across Pangea's center. The atmosphere itself was an engine, and every living thing existed within its currents. Even the color of the sky may have been subtly different. Higher concentrations of volcanic aerosols during periods of intense eruptions would have filled the air with fine particles, scattering sunlight and tinting the horizon. Some sunsets might have burned a deep red, their glow carrying across the flat open lands of the interior. At other times, when the air cleared, the sky would have stretched in an unbroken blue arc, vast and sharp, with a little moisture to soften it. The breath of Pangea also carried heat. Without the moderating influence of many smaller continents and oceans, the seasonal temperature swings were more intense. Summers in the interior baked under hot, dry air, while winters cooled sharply, the air turning thin and biting. The coastal regions were gentler, their air tempered by ocean breezes. But even there, the rhythms of the supercontinent could be felt. When the monsoon season arrived, humid winds swept to shore, feeding the forest with warm, moisture-laden air. When those winds shifted away, dry air reclaimed the land. And in this atmosphere, animals lived in lockstep with the air they breathed. Some evolved efficient lungs to pull oxygen from a thinning sky. Others became masters of stillness, conserving energy and heat and dryness. Plants adjusted their leaf structures, their pores opening and closing, to preserve water, while still drawing in the gases they needed to grow. Every adaptation was a response to the air, and every change in the atmosphere rippled through the web of life. But the most striking thing about Pangea's air was not just its chemistry, it was its reach. A single atmosphere wrapped every corner of the supercontinent. Winds that began in the deserts of the interior could sweep out to the coasts, carrying dust and minerals that would settle into distant soils. Moisture from the oceans could drift inland until it faded and fell. Air connected the deserts to the forests, the mountains to the plains, and every living thing to every other. To stand on Pangea and breathe would have been to draw in that entire world at once. The dry heat of its interior, the salt-tinged winds from its coasts, the faint traces of volcanic gases carried from far-off eruptions. Every breath was a reminder that on this single continent, air was not divided or contained. It was the common thread that linked one end of the world to the other. And as the atmosphere shaped life, life in turn shaped the atmosphere, setting in motion a feedback loop that would define this era and prepare the planet for the changes to come. For in Pangea's air, heavy with history and restless with motion, lay the seeds of everything that would follow. The world of Pangea was preparing for its next transformation. Its air, its deserts, its coasts, and its forests had already shaped the stage, and now life itself was beginning to respond. This was the age before the dinosaurs, an era in which the ancestors of future giants were taking their first steps. The Earth was not yet ruled by the towering creatures that would come later, but the foundations for their reign were being laid quietly, one adaptation at a time. During the late Carboniferous and into the Permian, life on land became more specialized. The forests near the coasts were dense, humid, and full of competition. Here, amphibians dominated the rivers and swamps, their lives tied closely to the water. But among them were new arrivals, reptiles, creatures that carried a revolutionary advantage, the amniotic egg. Unlike amphibians, reptiles no longer needed to return to water to reproduce. Their eggs, protected by shells and membranes, could survive on dry land. This single adaptation opened the door to the interior of Pangea, to the deserts and dry plains that amphibians could not reach. These early reptiles were not yet the massive predators or towering herbivores of later ages. Many were small, quick, and low to the ground, feeding on insects and other small animals. But some began to grow larger. Among them were the synapsids, a group of creatures that would eventually give rise to mammals. In the Permian, however, They were the dominant land animals, and their forms were as strange as they were varied. Some, like Dimetrodon, carried enormous sails on their backs, perhaps for regulating temperature or for display. Others had powerful jaws and sturdy bodies built for endurance, roaming the drier lands of the supercontinent in search of prey. In the forests and along the riverbanks, herbivorous synapsids browsed on ferns and seed plants. Their teeth adapted for grinding tough vegetation. They were stocky, slow-moving animals, but their size offered them protection. In this world of vast landscapes and harsh climates, being large was an advantage. It allowed them to travel farther in search of food, endure longer without water, and survive the swings of Pangea seasons. The insects of this age were still remarkable in their own right. With oxygen levels higher in the earlier periods of Pangea's history, some had reached sizes that would seem impossible now. Dragonflies with wings nearly a meter across glided over rivers. Millipede-like arthropods stretched several feet in length, crawling across the forest floor. Although their dominance was beginning to wane as oxygen levels declined, they remained a defining feature of the landscape, reminders of a time when the air itself had allowed life to grow to astonishing proportions. In the ocean surrounding Pangea, life was equally dynamic. Large predatory fish, armored with thick scales, hunted in the open waters. In the shallows, early sharks prowled, sleek and efficient, their lineage already well established along the coasts and in the smaller inland seas. Invertebrates like brachiopods, ammonites and crinoids populated the seafloor, filtering nutrients carried by the currents of Panthalassa. The oceans were vast and deep, but they were connected to the rhythms of the land. Dust from the deserts of Pangea carried nutrients into the sea, and floods from the coastal rivers replenished the coastal shelves with minerals that sustained marine ecosystems. Back on land, the first great experiments in size were beginning to appear. Among the synapsids and reptiles were forms that hinted at what was coming. Some grew heavier and more imposing, testing the limits of what the land could support. Their skeletons, preserved in stone, show sturdy limbs built to carry bulk and teeth designed for a range of diets. These were not yet the giants of the later Triassic and Jurassic, but they were their precursors, evolution's first attempts at filling the enormous spaces of Pangea with equally enormous creatures. The climate of the supercontinent drove this process forward. In the lush coastal regions, food was abundant. Forests produced layer upon layer of vegetation, and herbivores could feed almost without pause. In the arid interior, by contrast, survival favored endurance and size. Larger animals could travel farther for water and store energy. Over millions of years, these pressures shaped the bodies of the creatures that lived there, setting the stage for the rise of the great lineages to come. Predators followed. As herbivores grew larger, so too did the hunters that preyed on them. Early reptilian predators with long jaws and sharp teeth evolved to match their quarry in strength and speed. These arms races of size and power would continue into the Triassic, where they would give birth to the first true giants of the Mesozoic, the age of the dinosaurs. But even now, in this earlier time, the pattern was clear. Pangea was a world that rewarded adaptation on a grand scale. The interconnectedness of the supercontinent helped as well. With no oceans to block their path, species could spread across vast distances, carrying new traits from one region to another. A predator that evolved in one corner of Pangea could over time follow its prey into entirely different climates. Herbivores could migrate from the wetter coast to the drier interior, their populations branching and adapting to the unique conditions of each new region. Evolution did not happen in isolation here. It unfolded on a continental stage, and every movement of wind, every shift of the seasons, and every geological change rippled through that immense connected system. And while the giants of the future had not yet arrived, the groundwork was set. The forests were spreading, the deserts were waiting, the atmosphere was changing, and in the quiet spaces between survival and adaptation, life was preparing to grow larger, stronger, and stranger than ever before. Across the vast stretches of Pangea, the forests were unlike anything we know today. They were older, stranger, and built from forms of life that had long since vanished from the earth. These ancient woodlands were the lungs of the Supercontinent, shaping the atmosphere, anchoring the soil, and providing shelter for the growing diversity of animals that roam the land. To walk beneath their canopy would have been to step into a world both alien and familiar, a place where evolution was still experimenting with the building blocks of future ecosystems. In the humid belts near the coasts, the forests were dense and towering. Great seed ferns with fronds as broad as the span of a human's arms formed thicket so thick that little sunlight reached the ground. These plants, neither true ferns nor flowering trees, dominated vast areas of Pangea's lands. Their stems and leaves built sprawling networks of shade, under which smaller plants competed for every sliver of light. In this dim green world, the air was heavy with moisture, and the ground was layered with thick mats of decaying vegetation that would one day become the coal seams buried deep beneath modern continents. Towering above the seed ferns were the early conifers. These were the ancestors of the pines, firs, and spruces of today, but in the Permian and Triassic, they were pioneering giants. Their needle-like leaves allowed them to survive in a wider range of climates, from the wetlands to the drier uplands that bordered the interior of Pangea. Their wood, strong and reinous, supported trunks that reached skyward, creating vertical layers within the forest. Among these branches, small reptiles and early insects found refuge, their movements hidden beneath the evergreen canopy. Closer to the interior, where the climate grew harsher and rainfall scarce, the forests thinned. Here, drought-tolerant plants dominated, hardy conifers, low-growing shrubs, and cycads with stiff, leathery leaves. These cycad with their strange crown-like tops of fronds seemed like relics from an older, with time. They thrived in places where few other plants could take root, anchoring the soil and feeding the herbivores that ventured into the dry lands between the forests and the great deserts of land. Pangea's core. In some regions, especially near the coasts and river valleys, forests merged with vast wetlands. These swampy ecosystems were dominated by ancient horsetails and club mosses, plants that once reached heights far greater than their modern descendants. Their hollow, jointed stems formed dense stands along the water's edge, their roots binding the soil against the shifting currents. These wetlands were nurseries of life, sheltering amphibians that needed water to breed, while early reptiles patrolled the edges in search of prey. The forests of Pangea were not silent. Insects filled the air with a constant hum, their wings flashing in the dappled light. Giant dragonflies, their wings beating slowly, skimmed above clearings and riverbanks. On the ground, millipede-like arthropods crept through the thick leaf litter, while beetles and early ants began their quiet work of breaking down decaying plant matter. Every sound and movement in these forests was part of an intricate web that tied the entire ecosystem together. And where there was plant life in abundance, herbivores followed. Early synapsids and reptiles browsed among the ferns and cycads, their jaws adapted to grind through fibrous vegetation. Some carried squat barrel-shaped bodies to house powerful digestive systems capable of extracting every bit of energy from the tough plants of Pangea's forests. Their tracks, preserved in stone, crisscross ancient floodplains that were once shaded by trees, now long gone. Even predators depended on these forests, though not for food directly. The dense vegetation provided cover for ambush hunters. Smaller reptiles and early carnivorous synapsids stalked the shadows, their movements hidden by the layers of plants. The forests were both sanctuary and hunting ground, a place where every leaf and branch played a role in survival. The air in these forests would have felt different from the dry winds of the interior. Humid and heavy, it carried the scent of resin, wet soil, and decaying plant matter. Sunlight broke through in narrow shafts, striking the forest floor in fleeting patches. In the coastal lowlands, Fog sometimes rolled in from the ocean, wrapping the trees in a pale mist that lingered until the heat of the day burned it away. Farther north and south, where the climate cooled, the forests changed again. Conifers became more dominant, their evergreen needles adapted to survive in regions where winters could bring frost. These forests were sparser than their equatorial counterparts, but they were resilient, holding their ground even as the seasons turned. All across Pangea, the forests connected the land. They followed the rivers deep into the interior, stretched across the coasts, and climbed the foothills of mountain ranges born from the continent's great collisions. They were not a single unbroken expanse, but a network of green that bound the supercontinent together, feeding its air with oxygen and shaping the evolution of its creatures. In time, these forests would also become the stage for transformation. As climate shifted and the Earth's atmosphere changed, the plants that had ruled Pangea for millions of years would face new competition. But in this moment, during the height of the supercontinent's age, the forest stood at their peak, vast, untamed, and home to the first true foundations of the world that was still to come. Life on Pangea was not only written in the forests and deserts, but also in the creatures that moved across them. The supercontinent was home to an extraordinary array of animals, from the smallest crawling insects to the first powerful reptiles that would one day dominate the land. Each of them was part of an unfolding story of survival and adaptation, shaped by the climate, the atmosphere, and the boundless connected geography of Pangea. In the humid lowlands and coastal forests, insects ruled the undergrowth and the air above it. Oxygen levels in earlier ages had fueled their expansion into forms far larger than most modern species. Dragonflies with wingspans stretching close to a meter soared between the trees, their compound eyes fixed on prey that they captured with swift, precise movements. Their flight was steady and powerful, a sign of how much the atmosphere of Pangea had enabled these early aerial hunters. On the ground, giant millipede-like arthropods crept through the damp litter of decaying plants. Some of these creatures stretched several feet in length, their many legs rippling in waves as they moved slowly across the shadowed forest floor. They were detritivorous, consuming fallen leaves and rotting wood, playing a vital role in recycling nutrients back into the soil. Alongside them, beetles, primitive cockroaches, and early relatives of modern ants and termites formed bustling micro-ecosystems in the dark spaces beneath the canopy. These insects were not simply background life, they were the foundation of Pangea's terrestrial ecosystems. They fed on plants, broke down waste, and in turn became food for the first small reptiles that had left the swamps behind. This was a world in transition, where amphibians still lingered near rivers and wetlands, but reptiles were beginning to step farther inland, no longer tied to the water for reproduction. Their eggs, encased in protective shells, were a key to their independence. Among these reptiles were early napsids and diapsids, two groups that would eventually give rise to turtles, lizards, snakes, crocodiles, and even dinosaurs. But in the age of Pangea, they were still small, cautious creatures. They hunted insects among the roots of towering seed ferns or bast, in patches of sunlight that broke through the forest canopy. Their limbs were strong, their bodies low and agile, well suited for navigating the dense vegetation and uneven ground of this ancient world. The synapsids, the group that would ultimately give rise to mammals, were also thriving. Some were small insectivores, quick and sharp-eyed, darting between shadows in search of their prey. Others, like the early herbivorous synopsids, carried barrel-shaped bodies and strong jaws, using their size as both defense and a tool for processing the fibrous plants that grew in abundance across Pangea. They shared the forests with amphibians that had adapted to life on land, but still returned to the water to breed, clinging to the last remnants of an older age. In the wetlands and along the rivers, amphibians remained the dominant vertebrates. Some were small and nimble, their slick skin allowing them to breathe both in water and on land. Others were massive crocodile-like predators, with wide jaws and sharp teeth, waiting motionless beneath the surface for an unwary fish or reptile to draw near. These amphibians were relics of an earlier world, but in the rich, waterlogged environments of Pangea's coasts, they continued to hold their ground for millions of years. The interaction between these groups, amphibians, reptiles, synapsids, and insects, created a complex web of life. In the coastal forests, insectivorous reptiles relied on the dense insect populations, while amphibians preyed on fish and smaller creatures in the swamps. Larger synapsid predators began to test their strength against the other inhabitants of this interconnected world. Fossil trackways preserved in the rocks of ancient floodplains capture these moments. The prints of small reptiles zigzagging between the marks left by lumbering herbivores, with the faint impressions of predators trailing behind. Farther inland, in the drier zones of Pangea, reptiles became the true pioneers. Unlike amphibians, they did not need standing water to survive, and they followed the rivers and sparse vegetation deep into the continent's interior. Here, they evolved tougher skin to conserve moisture, stronger limbs for traveling over open ground, and behavior suited to a harsher climate. These inland reptiles represent one of the earliest examples of life fully adapting to the arid heart of Pangea, where rain was scarce and the sun was unrelenting. The insects followed them even there. Hardy species capable of withstanding heat and drought spread across the drylands. Termite-like insects may have begun to form colonies, burrowing into the soil and wood to build protected environments against the sun. In turn, the reptiles and early synapsids that hunted them adapted alongside their prey. Their movements, shaped by the shifting balance between predator and food. The forests, swamps, and deserts of Pangea were thus bound together not only by the land itself, but by the constant movement of life across it. Every plant fed an insect, every insect fed a reptile, and every predator carved its niche in a landscape so vast that no single ecosystem stood alone. The lack of oceans between these habitats meant that animals and plants could spread far more easily, sans 5U, than they can today, turning Pangea into a single interconnected stage where evolution played out on a continental scale. In this world, every creature was part of a grand experiment. The insects that grew large in the oxygen-rich air, the reptiles that shed their ties to water, and the synapsids that prowled the shadows were all pieces of a puzzle that would eventually give rise to the Earth's future rulers. But for now, they were simply survivors of a world still finding its balance. A world where the land was one, the air was heavy, and life was beginning to take its next great leap forward. As life spread across Pangea, one lineage of creatures began to take on shapes and traits that would eventually lead to us. These were the synapsids, sometimes called mammal-like reptiles, though in truth they were neither fully reptile nor mammal. They were a transitional group, a bridge between the cold-blooded hunters of the past and the two warm-blooded animals that would one day come to dominate the Earth. In the late Permian, the synapsids were already among the most successful animals on land. They came in many forms, from small, sharp-toothed insect hunters to massive, heavy-bodied herbivores that could rival the size of a modern rhinoceros. Their most distinctive feature was a single opening behind each eye in their skull, an evolutionary change that gave their jaw muscles room to expand. This seemingly small difference gave them stronger bites, faster strikes, and more efficient feeding than many of their reptilian rivals. One of the most famous early synapsids was Dimetrodon, with its long, sprawling body and the enormous sail rising from its back. It looked like a creature pulled from a world of imagination. That sail was not just for display. It may have helped regulate body temperature, capturing heat in the cool mornings and releasing it during the hottest hours of the day. In the unpredictable climate of Pangea, such an adaptation could mean the difference between life and death. But not all synapsids were predators. The ivorous forms like a Daphosaurus carried smaller sails and wide, blunt teeth, designed for grinding tough plants. These creatures moved slowly across the floodplains and forests of Pangea, feeding on cycads, ferns, and other hardy vegetation. Their bodies were built for endurance rather than speed, and their size helped deter smaller carnivores that prowled in their shadow. As the Permian period progressed, other synapsids emerged that pushed closer to what we would recognize as mammal-like. The therapids, for instance, began to show more advanced traits. Stronger limbs held more vertically beneath their bodies, differentiated teeth for slicing and chewing, and perhaps even early signs of whiskers or hair-like structures, though direct evidence of this remains debated. These features gave them an edge. They were faster, more efficient, and better suited to the varied climates of Pangea. Therapsids included formidable predators, such as gorgonopsids, sleek hunters with long saber-like teeth and muscular builds. They were among the top predators of their time, stalking the dry interior plains and river valleys of the supercontinent. Their skulls were more advanced than those of earlier synapsids, hinting at a shift toward quicker reflexes and sharper senses. In a world as vast and open as Pangea, these adaptations allowed them to chase prey across long distances and seize any opportunity to strike. Yet alongside these predators were herbivorous therapids like dinodons. These stocky, tusked creatures had beak-like mouths for clipping vegetation and powerful jaws for grinding it down. Fossil evidence suggests that some dissonants may have traveled in herds, moving together across the landscape in search of food. Their ability to survive in both the wetter coastal regions and the drier interior helped them spread across nearly every corner of Pangea, leaving their remains on continents that today lie oceans apart. What made these mammal-like creatures remarkable was their versatility. They were not tied to one environment or one way of life. Some thrived in the humid forests along the coasts, where plants were abundant and water was easy to find. Others adapted to the arid heart of Pangea, conserving energy and enduring long stretches without moisture. Their range was so vast that they became one of the dominant forms of life across the supercontinent. Their success also reshaped the ecosystems around them. As synapsids evolved new ways of feeding and hunting, they forced their prey and competitors to adapt as well. This constant evolutionary pressure created a dynamic, ever-changing world where survival meant keeping pace with the relentless arms race of life. In this way, the mammal-like creatures of Pangea laid the groundwork for many of the traits that would define their distant descendants: warm-bloodedness, efficient movement, and complex social behaviors. Even in the midst of their dominance, however, the world around them was shifting. Volcanic eruptions sent ash into the air. Tectonic forces strained the supercontinent, subtly reshaping its landscapes. The atmosphere itself fluctuated, its oxygen levels rising and falling. Through it all, the synapsids endured. They were not yet mammals, but they carried the blueprint of what mammals would become. To stand on Pangea and watch them move across the land would have been to glimpse the early outlines of a future still hundreds of millions of years away. Their powerful jaws, their sturdy limbs, and their ability to survive in a world of extremes marked them as the quiet architects of what was to come. They were not the largest creatures in their world, nor the most terrifying, but they were among the most enduring. And endurance in the harsh and restless age of Pangea was everything. So beneath the vast surface of Pangea, the earth was never still. Its crust was locked in a constant struggle with the forces rising from below. Heat built deep within the mantle, driving the slow but relentless movement of tectonic plates. Along the seams where continents had fused, the ground buckled and split, and from those cracks, fire emerged. Volcanoes were the pulse of the planet, and during the age of Pangea, their presence was inescapable. These volcanoes were not isolated peaks, scattered randomly across the land. Many rose along great fault lines where the tectonic plates met, forming chains that stretched for hundreds, even thousands of kilometers. In some places, they erupted steadily, releasing rivers of lava that hardened into new rock. In others, their explosions were sudden and catastrophic, sending ash and gases high into the atmosphere, changing the climate for years at a time. The evidence of this activity is still visible today. Ancient lava flows preserved in layers of stone trace the outlines of long-dead volcanoes. Beds of volcanic ash lie buried in the rock record, silent witnesses to the fury of a world still being forged. These eruptions were not rare events. They were a regular part of life on a restless supercontinent. The impact of this volcanic activity on Pangea was profound. Each eruption reshaped the land, carving out new mountains and burying valleys beneath hardened basalt. Vast plateaus were formed from layer upon layer of cooling lava, their surfaces later eroded by wind and rain into rugged landscapes. In the shadow of these volcanic regions, soils enriched by mineral ash fed new plant growth, creating patches of fertile ground amid otherwise harsh environments. Yet volcanoes did more than shape the land. They transformed the air. Each eruption released vast amounts of gases into the atmosphere, including water vapor, carbon dioxide, and sulfur compounds. Carbon dioxide, in particular, acted as a powerful greenhouse gas, trapping heat and amplifying the planet's already intense climate. Over millions of years, these emissions played a key role in driving the shifts in temperature that defined Pangea's environmental extremes. Sulfur gases, on the other hand, could have the opposite effect in the short term. When powerful eruptions sent sulfur aerosols high into the stratosphere, they reflected sunlight back into space, cooling the surface temporarily. These swings between volcanic warming and volcanic cooling created a planet that was not only vast but volatile, its climate shifting with every major eruption. Volcanoes also brought fire. The forests of Pangea, rich with resin-heavy conifers and dense undergrowth, were vulnerable to lightning strikes and, in some cases, to the heat and ashfall from nearby eruptions. Wildfires likely swept across large regions, clearing old growth and making way for new plant life. In this way, fire became a natural part of the planet's cycle, reshaping ecosystems and creating mosaics of burnt land and regrowth across the supercontinent. For the creatures of Pangea, these eruptions and fires were both threat and opportunity. The ash clouds could blot out the sun, disrupting plant growth and forcing herbivores to migrate in search of food. Predators followed in their wake, moving into new territories opened by shifting vegetation. In other places, volcanic activity created fertile regions where life flourished. Lava fields cooled into rich soils that supported dense forests, and rivers, redirected by eruptions, carved out new floodplains. One of the most dramatic reminders of this volcanic power came toward the end of the Permian period, when massive eruptions in what is now Siberia released enough gases to trigger profound changes in the atmosphere and oceans. These eruptions, known today as the Siberian Traps, poured out lava over an area larger than most modern countries, sending shockwaves through Pangea's ecosystems. Though this event marked the beginning of one of Earth's greatest mass extinctions, it also underscored how deeply the planet's geology and its life were connected. Even in less catastrophic times, volcanoes gave Pangea its rhythm. Their eruptions marked the passing of ages, each layer of ash and lava a page in the planet's history. They were reminders that beneath the forests, rivers, and deserts, the Earth was alive, a vast engine of heat and pressure that never truly rested. Standing on Pangea during one of these eruptions would have been a humbling experience. Ash would have darkened the sky, lightning sparked by volcanic plumes would have flashed in the distance. The air would have carried the acrid scent of sulfur, while tremors rolled through the ground, like the slow, steady breathing of the planet itself. And when the eruption ended and the sky cleared, life would begin again, filling the land that fire had remade. In this way, volcanoes were not only destructive, they were part of the cycle that shaped Pangea, feeding its forests, carving its mountains, and rewriting its landscapes. They gave the supercontinent its pulse, a deep, unending rhythm that echoed through every corner of the ancient world. For millions of years, Pangea stood as one. Its mountains, deserts, and forests stretched from one horizon to the next, bound together under a single sky. But the same forces that had forged it from drifting continents never stopped moving. Deep beneath the surface, heat from the Earth's mantle pressed upward, straining the seams that held the supercontinent together. Slowly, almost imperceptibly, cracks began to form. These cracks did not appear all at once. At first, they were nothing more than rifts, long, narrow valleys where the crust stretched and thinned under immense pressure. In some places, magma rose into these gaps, feeding chains of volcanoes that marked the earlier signs of separation. Over millions of years, these rifts widened. Where land had once been solid and unbroken, new basins began to form, hinting at the oceans that would one day divide Pangea into the continents we know today. Geologists studying these ancient rift zones have found their scars preserved in stone. In what is now eastern North America and western Africa, the rock layers bear the evidence of this slow tearing. Ancient faults traced the lines where the crust was pulled apart, while thick deposits of basalt tell the story of magma welling up from deep below. These features are the first fingerprints of the Atlantic Ocean, though in Pangea's time, the ocean itself was still millions of years away. The splitting of Pangea was not a single event, but a process that unfolded in stages. At first, the cracks were local, limited to long valleys that filled with lakes and rivers. Over time, as the crust continued to stretch, these valleys deepened and volcanic activity intensified. Eventually, water from Panthalassa began to seep into the widening gaps. The Earth's single unified landmass was beginning to fracture, its edges slowly surrendering to the sea. As the land pulled apart, the climate shifted once again. The interior of Pangea, already arid, became even more isolated as rifts deepened and mountain ranges rose along their edges. Meanwhile, the regions near the growing rift valleys saw an increase in rainfall. Their lowlands transformed into fertile basins where rivers gathered and forests flourished. Life followed these changes. Plants and animals that once ranged freely across Pangea now began to encounter the first true barriers in their world. Valleys, highlands, and expanding bodies of water that divided one population from another. The splitting of Pangea also altered the winds. As the supercontinent's edges shifted and new seas began to open, atmospheric currents adjusted in response. Moisture from the oceans reached new regions, while other areas dried further. It was a slow, uneven process, but it marked the beginning of the end for the single borderless world that had dominated for so long. Yet, even as the land cracked, life continued to thrive. Early reptiles evolved into new forms, some of which would give rise to the first true dinosaurs. Synapsids adapted to the changing conditions, their descendants moving steadily closer to the traits of modern mammals. The forests spread and retreated with the shifting climate, and the deserts continued to expand and contract in the supercontinent's vast interior. The great breakup of Pangea would not be completed for tens of millions of years, but its first movements had begun. What had once been one world was slowly, steadily becoming many. The continents we know today, North America, South America, Africa, Europe, and eventually Asia, were written in those first rifts like a blueprint waiting to unfold. To witness Pangea during this time would have been to see a land both familiar and unsettled. The ground might tremble with distant volcanic activity. Rivers might cut deeper into rift valleys that widened a little more with each passing age. Mountains might rise where the Earth's crust buckled under strain. It was a world in transition, its future continents quietly preparing to drift apart. And yet, even as Pangea cracked, it was far from gone. For millions of years, the supercontinent would endure, its ecosystems adapting to every shift. Life moved with the land, filling every new valley and plain. But the first fractures were there growing, and with them came the slow reshaping of the Earth into the planet we recognize today. As Pangea stretched and shifted under the slow pull of tectonic forces, its surface was bound together, not only by its land but also by its rivers. These waterways were the lifelines of the supercontinent, cutting across thousands of kilometers, feeding forests, carving valleys, and stitching together ecosystems from one edge of the world to the other. Unlike today, where oceans separate the great river systems of each continent, Pangea's rivers flowed across a single unbroken land. They knew no borders, and their influence reached from the wet coast to the driest heart of the Stean. Many of these rivers began high in the mountains that had been born from Pangea's great collisions. Snowmelt and rainfall at these heights fed torrents that cut deep into the rock, carrying with them minerals and sediments ground down over millions of years. As they descended from the highlands, they broadened into sweeping rivers that wound through the forests and plains, their waters gathering strength as countless streams joined them along the way. These rivers became the arteries of the supercontinent, sustaining life in a world of extremes. Along their banks, dense vegetation thrived, towering conifers and sprawling seed ferns lined the floodplains, their roots binding the soil against erosion, while their fallen leaves enriched the ground with nutrients. Insects swarmed in these lush corridors, their buzzing filling the air above the shallow backwaters, while amphibians hid in the mud and reeds, feeding on whatever they could catch. Small reptiles stalk the edges of these wetlands, hunting insects or darting into the water to escape larger predators. For the animals of Pangea, these rivers were more than water. They were pathways. Herds of herbivorous synapsids followed their winding courses, feeding on the vegetation that grew in abundance along their banks. Predators shadowed them, lurking in the cover of the trees or waiting where the rivers narrowed, ready to strike. Over time, these waterways became natural highways of migration, connecting distant regions of the supercontinent and allowing species to spread from one end of Pangea to the other. The scale of these rivers was staggering in the great interior. Some of them may have flowed for thousands of kilometers before reaching their final destination, either vanishing into vast inland basins or spilling into shallow coastal seas. Without oceans to divide the land, rivers could run across what today would be multiple continents, crossing landscapes that range from humid forests to semi-arid plains, and eventually to the edge of the deserts at Pangea. When heavy rains came during the monsoon seasons, these rivers swelled far beyond their normal bounds. Floodwater spread across the floodplains, leaving behind rich layers of silt as they receded. These fertile soils supported dense plant life, drawing in animals from every direction. Fossilized sediments from these ancient floodplains still bear the footprints of the creatures that once gathered there. The broad tracks of herbivores, the clawed marks of predators, and the delicate impressions of smaller reptiles and insects. Not all of Pangea's rivers were gentle and meandering. In some regions, fast-moving currents tore through steep valleys, grinding away rock and carrying enormous amounts of sediment toward the lowlands. These powerful rivers carved canyons and created vast alluvial fans, spreading out like fingers where they finally slowed. Each one reshaped the land over time, leaving behind a record of shifting channels and vanished courses etched into the rock. And yet even the quietest streams played their part. In the driest parts of Pangea's interior, small seasonal rivers, ephemeral ribbons of water that flowed only after rare storms, became the difference between life and death. These brief floods left behind pools that sustained animals and plants long after the rains had ended. Tracks pressed into the drying mud tell the story of creatures that came to drink, their paths crossing at these temporary oases before vanishing again into the endless desert. Beyond their immediate impact, Pangea Rivers helped tie the supercontinent together in ways that extended far beyond their banks. The sediments they carried nourished ecosystems hundreds of kilometers away. As minerals from the mountains were deposited across the plains, dust from the interior deserts was swept into these waterways by the wind, only to be delivered to the coasts where it enriched the soils of distant forests. Water connected Pangea's extremes, its mountains, deserts, and coasts into one vast interdependent system. For the people who study these ancient rivers today, the evidence is clear. In the rocks of North America, Africa, and Europe, there are deposits of the same ancient river, systems preserved across continents, now separated by oceans. Their patterns match, their sediments align, and their fossils tell the same story. Once long ago, these rivers flowed across a single earth. To stand on the banks of one of these rivers would have been to see life gather in abundance. Herds of plant-eaters crowding the shallows, predators stalking the edges, insects rising in clouds from the reeds, and amphibians slipping quietly into the water. The air would have been heavy with the scent of wet soil and vegetation, the sound of flowing water blending with the calls of distant animals. These rivers were more than geography. They were the lifeblood of a world that had not yet been divided. And as Pangea began to crack and shift, its rivers would change too, rooted by the slow upheaval of the land. But for millions of years, they ran without borders, uniting an entire supercontinent under their endless flow. Above Pangea, the sky was not silent. It carried the voice of the supercontinent, a language of wind, storms, and shifting air that shaped the land below and the lives of everything that lived upon it. To stand beneath that sky would have been to hear a world in motion, its vastness filled not with stillness, but with an unending rhythm of weather that swept from one horizon to the other without pause. The winds were the first and most constant part of this sound. With nearly all the land gathered into one mass, there were few obstacles to interrupt their flow. Air currents that began over the endless expanse of Panthalassa could travel for thousands of kilometers across Pangea before slowing. In the coastal regions, these winds arrived heavy with moisture, brushing through forests and bending the crowns of towering conifers. Farther inland, the same winds grew thin and dry, hissing across the deserts, carrying dust and sand until it blurred the horizon. In every corner of the supercontinent, the wind gave Pangea its voice. During the monsoon seasons, that voice grew louder. Warm air rose from the heated land in the interior of Pangea, pulling in massive surges of oceanic moisture. These monsoonal winds swept across the coasts with heavy rains, drumming against the forests and filling rivers until they overflowed onto the floodplains. Insects filled the air in the damp heat that followed, while amphibians and reptiles emerged from their hiding places to hunt and feed. For weeks, the sky was alive with sound, the rush of wind, the roar of water, and the constant patter of rain on leaves. But when the monsoons retreated, silence returned to the interior. Dry season winds blew across the heart of the continent, stripped of moisture, their currents sighing over dunes and rocky plains. In these moments, the sky above the desert must have seemed enormous. A pale dome without clouds, the air trembling in the heat. At night, that same sky would have transformed into a canopy of cold brilliance, its silence broken only by the faint whistle of wind between the stones and the calls of creatures that had adapted to the dark. Storms were another voice in this ancient atmosphere. With such vast distances and powerful wind patterns, thunderstorms could grow to staggering size, their anvils towering high into the stratosphere. Lightning split the sky in jagged flashes, followed by the deep rumble of thunder rolling for miles across the open land. In the forests near the coasts, these storms would have brought torrents of rain. In the arid interior, their clouds often passed without releasing more than a few drops, a reminder of how far the heart of Pangea lay from the ocean's reach. Volcanoes added their own sounds to the sky. Eruptions along the rift zone sent ash and gases high above the land, where the winds carried them. Across the supercontinent, These events sometimes turned day to twilight, muffling the sun behind a gray haze. When volcanic plumes collided with the atmosphere, lightning crackled within them, an eerie storm of fire and ash that must have echoed across the landscape for days. The sky also carried subtler voices, the quiet movements of air that shaped life in ways less dramatic, but no less important. Gentle breezes spread the spores of plants and the seeds of the earliest conifers, carrying them far from their parent trees. Migrating animals followed the shifts in seasonal winds, their movements in step with the changing climate. Even the dust storms of the interior deserts had their own purpose, lifting fine particles into the air and scattering them across forests and wetlands, thousands of kilometers away, enriching the soil with minerals from distant lands. In this world, the sky was not a background. It was an active part of Pangea's living system, a link between the ocean and the land, between the deserts and the forests. Every change in temperature or pressure rippled outward, touching everything beneath it. If you had stood on the banks of one of Pangea's great rivers and listened, you might have heard the hum of insects in the still air, the sigh of wind in the conifer branches, and in the distance, the low growl of thunder from a storm building far away. In the interior, you might have heard nothing but the dry rasp of air over sand, a silence so complete it was broken only by the sound of your own breathing. Near the coasts, the wind would have carried the smell of salt and the cries of creatures living where the forest met the sea. Day after day, season after season, this ancient sky wrote its story across the land, shaping every climate and every living thing. It was not quiet, but it was steady, its rhythm older than mountains, older than rivers, older even than Pangea itself. And though the continents would one day drift apart, and new skies would form above them, the voice of that ancient atmosphere lingers still in the rock layers, in the fossilized remains of forests and deserts, and in the very patterns of wind that continue to circle the earth today. For millions of years, Pangea thrived under its vast sky, its rivers, forests, deserts, and coasts, shaping a world filled with extraordinary life. But nothing on Earth remains unchanged. The same planet that nurtures life also tests it, and during the late Permian, those tests became severe. It was a time of fire and silence when the greatest extinction event in the planet's history struck, and nearly emptied Pangea of its living inhabitants. The Permian Triassic extinction, often called the Great Dying, was unlike anything before or since. Around 252 million years ago, the Earth shifted violently. Vast volcanic eruptions, most dramatically in the region now known as Siberia, poured out unimaginable volumes of lava and gas. For hundreds of thousands of years, these eruptions transformed the atmosphere. Ash clouds blocked sunlight. Sulfur and carbon dioxide filled the sky. The air itself became heavy with the breath of a world in crisis. Temperatures soared. Greenhouse gases from the eruptions trapped heat, pushing the planet into one of the warmest intervals in its history. The interior of Pangea, already a land of extremes, became even harsher. Rain grew scarce, rivers dried, and the great deserts expanded until they reached farther than ever before. In the oceans surrounding the supercontinent, heat stripped away oxygen, leaving vast dead zones where life suffocated. The effects rippled across every ecosystem. The lush forests near the coast withered. Many of the great synapsids, the dominant mammal-like reptiles of the time, disappeared. Insects, which had thrived for hundreds of millions of years, suffered a sudden and catastrophic collapse, one of the only known mass extinctions in their history. Amphibians, once the rulers of Pangea's waterways, dwindled as droughts and heat drove them to the edges of survival. And yet, life did not end. It never does. While most species perished, a few endured, clinging to the scattered refugees that remained. Some of the smaller synapsids built for efficiency and survival managed to weather the storm. Their compact bodies required less food and water, giving them an advantage in a world stripped of abundance. Early reptiles, too, persisted, especially those adapted to drier conditions. Their tough skin, strong lungs, and water-conserving physiology gave them the tools to outlast the chaos that surrounded them. In the oceans, while many species of fish and invertebrates vanished, a few survivors adapted to the low oxygen waters, holding on until the seas slowly recovered. Even the plants of Pangea had their champions. The towering forests were cut down to remnants, but hardy conifers and drought-tolerant species endured, spreading again once the skies began to clear. These survivors were not the largest or most dominant creatures of their time. They were the quiet ones, the resilient ones, life forms that could bend without breaking. The recovery was slow. For millions of years, the world remained scarred. The once lush landscapes of Pangea were sparse, dominated by small, hardy plants and the scattered remnants of the animals that had made it through. But from this silence, a new order began to emerge. The survivors diversified, filling the empty spaces left by extinction. Small synapsids evolved into new forms, many of them edging closer to the traits that would one day define mammals. Reptiles freed from their competition spread into new niches, setting the stage for the rise of the first dinosaurs. The extinction reshaped Pangea not only in terms of life, but in the balance of its ecosystems. Where once the forests had been dense and the rivers crowded with amphibians and insects, the land now opened wide for the pioneers of the Triassic. These were creatures built for a harsher earth, descendants of the few that had endured the heat and hunger of the Great Dying. Their world was quieter, emptier, but it was also full of opportunity. Even the sky would have seemed different after the catastrophe. Without vast forest to pump moisture into the air, rainfall patterns shifted. Dust from the desert spread farther. The air was thinner, drier, and often hazed with the lingering traces of volcanic activity. It was a humbler world, but it was ready to begin again. In the silence that followed, evolution worked patiently. The survivors of Pangea were not the giants of its earlier ages, but they carried the seeds of what was to come. In their smallness, in their ability to endure, they represented a new kind of life, one defined not by dominance, but by persistence. They would rebuild the ecosystems of the supercontinent, piece by piece, and in time, they would give rise to the next great chapter of Earth's history. The world had been broken, but it was not dead. Out of that stillness, new life would rise, and Pangea, though changed, would remain the stage upon which it would happen. When the silence after the Great Dying began to fade, Pangea stood as both a scarred and promising world. The supercontinent was stripped of much of its former abundance, but its very scale and its empty spaces offered something extraordinary, a new beginning. What survived would shape the future of life on Earth, and the geography of Pangea itself determined how that future would unfold. With nearly all land gathered into one immense mass, there were no oceans to isolate species from one another. The survivors of the Paran extinction, small synapsids, resilient reptiles, and hardy plants, had a single continuous stage on which to spread. Populations could travel across vast distances without ever needing to cross a sea. This freedom of movement allowed life to mix in ways that would have been impossible on a divided planet. A creature that evolved in what is now South America could wander northward into regions that would one day be North America, or even east, toward areas that would later become Europe or Asia, leaving its descendants scattered across half the world. This interconnectedness accelerated evolution. When species met, they competed. When they competed, they adapted. Pangea became a vast laboratory, a place where every change in climate, every shift in the land, and every new adaptation rippled outward, influencing life across the entire supercontinent. This was why the Triassic period, which followed the Permian extinction, was an age of experimentation. The world was full of ecological vacancies, and evolution rushed to fill them. Small synapsids that had survived in the margins of the Old World diversified into new forms, some of them edging closer to what we would one day recognize as the earliest mammals. They remained small, mostly insect eaters, scurrying through the undergrowth of Pangea's recovering forests. Their size was no disadvantage. In a land still recovering from disaster, smallness was a strength. It meant they needed little food, could hide from predators, and could exploit the countless overlooked corners of the supercontinent's ecosystems. Reptiles, too, seized this moment. Freed from many of their competitors, they evolved into a staggering variety of shapes and sizes. Some became swift, agile predators. Others grew bulkier, turning into the first, larger bivivorous reptiles that roam the plains and river valleys of Pangea. Among them were the ancestors of the first true dinosaurs. Still small and relatively unremarkable at this stage, but carrying the potential to dominate the planet in the ages to come. Plants played an equally important role in this new world. The forests of Pangea, though changed, spread again across the coasts and river valleys. Conifers reclaimed the uplands. The evergreen needles adapted to the seasonal swings of the supercontinent's climate. Seed ferns and cycads took root in the warmer regions, their sturdy forms feeding the growing herbivore populations. Even the dry interior of Pangea supported patches of hardy vegetation, osiers of green that became stepping stones for life, moving across the deserts. The geography of Pangea also influenced the planet's climate in ways that shaped evolution. Its vast interior remained dry and harsh, favoring animals and plants that could endure extremes of heat and drought. Along the coasts, where ocean winds brought rain, ecosystems were more stable and abundant, supporting larger communities of plants and animals. This contrast between the coasts and the interior ensured that no single type of life could dominate everywhere. Instead, evolution carved out specialized solutions for every corner of the supercontinent. Even the great rivers of Pangea helped shape its future. These waterways served as corridors of life, linking distant regions and allowing species to spread further than they otherwise could. In their floodplains, rich soils supported dense vegetation, and those green belts became highways for migration. Fossil evidence shows that creatures living on opposite sides of Pangea often shared striking similarities, proof that these river corridors connected the entire continent like threads in an enormous web. And yet, for all its unity, Pangea also planted the seeds of division. The first rift valleys that would eventually tear it apart were already beginning to form. These rifts created isolated habitats where populations of plants and animals became separated from one another. Over millions of years, this isolation would lead to new species, each one adapted to its own environment, each one carrying a piece of Pangea's legacy. The supercontinent's influence would reach even further into the future. The animals that spread across it, those early reptiles, mammal-like synapsids, and the first true dinosaurs would go on to dominate not just Pangea, but the smaller continents that would later emerge when it finally split apart. Its forests and deserts would shape the evolution of plant life that still has descendants on today. Even its climate patterns would leave marks in the geological record that scientists can still trace, a reminder of how profoundly this single landmass once controlled the Earth's systems. To stand on Pangea during this time would have been to see a world in the middle of transformation. The scars of the Great Dying were still visible, but life was returning, cautious at first, and then unstoppable. The sound of the wind through the conifers, the tracks of small reptiles in the mud of the riverbanks, and the distant calls of predators were the proof of a planet rebuilding itself. Pangea was more than a supercontinent, it was a crucible. From its extremes, its vastness, and its connectedness, it forged the foundations of the modern world. Everything that came after, from the rise of the dinosaurs to the first mammals, and eventually to us, was shaped in some way by the land and climate of this ancient unified Earth. For millions of years, Pangea had been the center of everything. Its deserts, rivers, forests, and mountains stretched endlessly beneath a single sky, its life roaming freely across a land without borders. But even as it shaped the future of Earth, the first deep fractures had already begun. Slowly, almost silently at first, the supercontinent that had united the world started to break apart. The process was not sudden. It unfolded over tens of millions of years, driven by the same forces that had once brought the continents together. Heat built deep in the mantle, pressing upward against the crust. Rifts opened, splitting the land into great valleys, where lava welled up from the Earth's interior. These rifts were the first hints of separation, the earliest marks of the map we know today. In the regions that would one day become the Atlantic Ocean, cracks appeared between what is now North America and Africa. At first, these were not oceans, but long, low basins, dotted with lakes and rivers. Over time, they deepened. Water from Pangea crept in, filling the rifts, and the first narrow seas were born. On the other side of Pangea, the land that would become India, Australia, and Antarctica began to drift slowly away from Africa, pulled by the same tectonic forces. These changes reshaped not only the land, but also the climate. As Pangea fractured, new coastlines formed, and with them came fresh sources of moisture. Regions that had once been dry began to receive rain from the growing oceans. The great interior deserts which had stretched unbroken across the heart of the supercontinent gradually shrank. Meanwhile, other areas grew drier, cut off from the humid winds by rising mountain ranges or the changing positions of the drifting land masses. Life responded in kind. Species that had once roamed freely across Pangea found themselves divided by widening seas and growing rift valleys. Populations were isolated, separated from one another by geography for the first time in hundreds of millions of years. From this isolation, new species began to emerge, the ancestors of familiar lineages. Dinosaurs, early mammals, and the first true crocodiles evolved in these divided worlds, each group adapting to the new realities of a planet no longer whole. The breakup of Pangea also changed the oceans. As the Atlantic widened, it became a new pathway for currents that would eventually reshape the planet's climate. Pangea, once the single vast ocean surrounding Pangea, now began to share its dominance with new seas that carved their way into the supercontinent. These changes would not only influence weather and rainfall, but also the migration of marine life, opening new habitats and closing others. On the land, volcanic activity accompanied the slow separation. Along the rift zones, magma surged upward, creating vast lava flows and reshaping the landscape. These eruptions released gases into the atmosphere, sometimes warming the planet further and driving dramatic swings in climate. The land that had once been united under a single rhythm of wind and weather was now becoming a mosaic of smaller worlds, each with its own emerging character. For the creatures of this time, the changes were profound. Dinosaurs, which had first appeared when Pangea was still whole, now began to spread across the drifting continents, adapting to the climates and landscapes that shifted as the land pulled apart. Early mammals followed similar paths, finding their own refugees in the forests and along the two river valleys of these newly forming lands. What had once been one interconnected world was slowly splintering, setting the stage for the diversity that would define the Mesozoic era. If you could have stood on Pangea during its long goodbye, you might not have noticed the change from one generation to the next. The land would have seemed solid, the forests would still have stretched to the horizon, the rivers would have continued their endless flow. But over millions of years, the cracks deepened, the seas widened, and the single great landmass was quietly transformed into the world of separate continents we know today. This was not an ending so much as a transition. Pangea had given life the chance to spread, to evolve, and to mix in ways no other arrangement of the continents ever could. Its slow breakup did not erase that legacy. It carried it forward, dividing the descendants of Pangea's creatures across new lands and new climates, where they would continue to change and adapt for millions of years to come. The supercontinent had begun its long farewell, but its influence would echo far beyond its own lifetime, written into every ocean current, every mountain range, and every living thing that still walks the earth. Even though Pangea is long gone, its presence has never truly left us. The continents we know today, split apart by oceans scattered across the globe, are still shaped by its memory. Its mountains, its rivers, its deserts, and even the living things that walk the earth, all carry traces of that time when the world was one. The echo of a single earth lingers in the land beneath our feet and in the patterns of life that bind us to a much older history. You can see this echo in the rocks themselves. The Appalachian Mountains of North America share their ancient roots with the mountains of Scotland and Morocco. Once they were part of the same range, raised high when Pangea was forged, their peaks standing shoulder to shoulder before drifting apart. Today, they are separated by the Atlantic, but their stone tells the same story. Their layers, still aligned like pieces of a puzzle, pulled apart but never forgotten. You can hear it in the fossils too. Creatures that once roamed freely across the supercontinent left their bones scattered from one end of the world to the other. The same species of early reptiles, the same plants, even the same insects appear in rock formations on continents now divided by entire oceans. Their remains are silent witnesses to a time when no sea stood between them, when the earth was a single, unbroken stage for life to play out its story. Even the winds and waters still carry Pangea's mark. The great ocean currents that circle our planet today trace their origins to the first openings of the Atlantic and Indian Oceans, born from the fractures that split the supercontinent. The monsoon patterns that drench South Asia and Africa are shaped in part by the positions of the 8 drifting continents, remnants of movements that began when Pangea first cracked and slowly drifted apart. And life itself has not forgotten. The ancestors of mammals, dinosaurs, and countless other lineages were all molded by the conditions of Pangea. Its vast deserts hardened creatures to endure drought and heat. Its endless forests sheltered small survivors who would one day become the first mammals. Its rivers and coastlines taught life to move, to spread, and to adapt to a planet where the rules of survival were constantly rewritten by shifting climates and restless ground. Even in our own bodies, in the deep structure of our bones, and the genetic memory written in our cells, there is a link, an unbroken line that runs back through millions of years to that single unified world. The echo of Pangea is not just a relic of the past, it is a force that continues to shape the present. Every mountain range that rises, every earthquake that shakes the ground, every drift of the ice beneath our feet is part of the same cycle that built and broke that ancient world. We live on a planet still in motion, still carrying the restless energy that once drew the continents together and then pushed them apart again. If you could stand on the highest peak today and look out across the earth, you would see a world divided by oceans and continents. But if you looked deeper beneath the surface, beneath the lines we draw on maps, you would find the same foundation, the same stone that once formed the floor of a single earth. And if you listen closely in the slow grind of tectonic plates and the distant roar of the sea, you can still hear it, the low, steady echo of a world that was once whole. Pangea is gone, but it is also everywhere. It is in the mountains that were born of its collisions, in the creatures that evolved upon its soil, and in the quiet, unending drift of the continents that will one day gather again. The earth has not stopped moving, and as it turns and shifts, it carries with it the memory of the time when all land was one, when every horizon was connected, and the sky arched unbroken above a single boundless world. And so the story of Pangea does not end with its disappearance. It lingers in every mountain range, every current of wind, and every living thing that traces its lineage back to that ancient unified earth. We walk across land that was once joined, breathe air shaped by the forest that once covered it, and study fossils of creatures that roamed a world without borders. Pangea reminds us that our planet has never been still. Continents drift, oceans open and close, climates shift, and life adapts. What was once one world became many, and in the far future, those many worlds may one day converge again. The Earth is always rewriting itself, and everything we see around us is only a chapter in a story that began long before us and will continue long after. If there is a lesson in Pangea, it is that change is the rule, not the exception. Yet within that change is an unbroken thread, a connection that ties the world we live in to the deep past. When we look at a map of the modern Earth, with its scattered continents and wide oceans, it is easy to imagine distance and separation. But beneath those seas, in the slow movement of the crust and the shared history carved into stone, the Earth is still one. Pangea was not just a place. It was a moment when the planet gathered itself into a single whole. And though that world has gone, its echo is still with us, carried quietly in the ground beneath our feet, and in the restless motion of the Earth itself. The continents will keep drifting, the sky will keep shifting, and the memory of Pangea will remain an ancient reminder that our world has always been larger, stranger, and more connected than it seems.